Hello class, this is Ms. Riggins coming to you with the first video of the new school semester. Yesterday in class we worked on the Pythagorean theorem, which is a topic you learn with right triangles in middle school, and we practiced on finding the third side of a right triangle based on Pythagorean theorem. But the only thing to note is that the Pythagorean theorem only works if it is a right triangle. If it's not a right triangle, then c squared does not equal a squared plus b squared. Well, we're going to use that to determine what kind of triangle it could be if we know all the side lengths. So let's say over here we have three different triangles, and they look like right triangles, but hopefully by now you should know that just saying, oh, they look like right triangles is not a guarantee that they are. So let's say that we do know all the distance measurements of each of the triangles, each of the sides of the triangles. Well, based off here, can we just look at this and say, oh, well, then that's the right triangle just because we know the distance measurements? No, we can't. So in order for us to determine if it is a right triangle, we're going to test to see if it holds up to the Pythagorean theorem, which means does c squared equal a squared plus b squared? That's what we're trying to figure out. Does c squared equal a squared plus b squared? So in order to figure out that information, we have to first be able to determine what is c. Now, in a right triangle, c is the hypotenuse, but also in a right triangle, c is the side across from the right angle, which is the largest angle, so therefore c is the longest side of the right triangle. Well, if I'm going to be using the Pythagorean theorem to test to see if a triangle is a right triangle, I need to use c being the longest side, whether I know if it's a right triangle or not. So over here, if we take a look here, we can see that for each of these triangles, the longest side in this case is AC because it has the longest side length. In this case, it's DF. In this case, it's GH because these are the longest side lengths of each of the three sides. So in order for us to determine whether or not these triangles are right triangles, now we need to figure out what the sum of a squared plus b squared is. So let's take a look at this first triangle, triangle ABC. We've identified that C is 7.39. So when we compare this length squared times the sum of the squares of these two lengths, these are the values that we get. So in this case, which measurement squared is the largest? Is it the C squared or is it the A plus B squared? Well, as you can see, they're very close, but but they're not equal. So therefore, we cannot say that this is a right triangle because c squared does not equal a squared plus b squared. Let's take a look at triangle DEF. Here are the measurements, and which measurement squared is the largest? Is it the c squared or is it the a squared plus b squared? Well, actually, they're not equal, so therefore, this triangle is also not a right triangle, because c squared does not equal a squared plus b squared. Let's take a look at this last triangle, GHJ. In this case, c squared is 46.14 centimeters squared, and the sum of the a squared and the b squared is 46.14. So in this case, they are equal. So that means that since c squared is equal to a squared plus b squared, that this triangle is the only right triangle. So now that we know that these first two triangles are not right triangles, how can we determine what type of triangle they are if they're just not right triangles? Can we be more exact? Because we also have acute and obtuse triangles. So let's take a look at the actual angle measurements for these three triangles. So here we can see triangle ABC, we don't have a right angle. Triangle DEF, we don't have a right angle. We have something that's close to a right angle. And triangle GHJ, we do have a right triangle, so that's why we know that this is a right triangle. But what kind of triangle is ABC based off the angles? Well, we can classify it as an acute triangle, and the reason why we can classify it as an acute triangle is that all the angles are less than 90 degrees. So we know that this is an acute triangle, and based off the angles for triangle DEF, we can see that one of the angles is larger than 90 degrees, so therefore we can classify the second triangle as an obtuse triangle. Okay? And of course, we already had determined this was a right triangle. Well, there actually is a way that we could have determined and classified the type of triangle by the angles without actually knowing the angles. And that's all based off Pythagorean theorem. So let's go back to that. So remember earlier we said that for this first triangle, c squared was not equal to a squared plus b squared. But what kind of angle, what kind of symbol should go there besides just the not equal sign? Well, since in this case c squared is less than a squared plus b squared, then the symbol that can go there is the less than symbol. And in this case, since c squared is greater than a squared plus b squared, we can take away the not equal sign, and we can be more specific and say that c squared is greater than a squared plus b squared. So that's something important to note, that when c squared is less than a squared plus b squared, we have an acute triangle, and when c squared is greater than a squared plus b squared, we have an obtuse triangle. And of course, you know that when c squared is equal to a squared plus b squared, we have a right triangle. So let's take a look at our notes on page 109. Now the notes on page 109, as we can see, they start off with talking about Pythagorean triples and what Pythagorean theorem is. But then we have what's called the converse, because remember the Pythagorean theorem says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs. So if we were to switch it around and say if the sum of the length of the squares of the other two sides, hold on, let me clarify that. It says that if the square of the length of the longest side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is and we can say right triangle because of the fact that we're talking about equals. Because if it wasn't equals, we really wouldn't know what we could say it's not a right triangle. So in this case, since it is equal, put that in big sayings, then that means we know that it's a right triangle. Okay? And so that's important to note. But a little bit further on down, we have these theorems that are based off the converse, which says that if the square of the length of the longest side of a triangle is less than, i.e. less than the sum of the squares of the lengths of the other two sides, and the triangle ABC is what type of triangle? Well, we know it's not a right triangle, and based off of our examples earlier, when c squared was smaller than a squared plus b squared, we ended up with what type of triangle? An acute triangle. So that means we have a way of determining if a triangle is acute without knowing its side lengths. All we have to do is determine is c squared smaller than a squared plus b squared. And in theorem 7.4, when we have here that they say if the square of the length of the longest side is greater than the sum of the squares of the lengths of the other two sides, then the triangle we know is not a right triangle, but it is also, if you said an obtuse triangle, you're absolutely correct. Now at the bottom of the notes on page 176, it's another chart that basically summarizes the three theorems, but that's basically it. So we have a way of determining, classifying a triangle not by its angles without knowing a single measurement of the angle. If we know the lengths of all the sides of the triangle, we can determine either by taking c squared and comparing it with a squared plus b squared what type of triangle it is. And that's it.